Hello everyone, welcome to my channel. You have built your rack pipeline, chunking is done, embedding is done, you're ready to store your vectors. So you Google best vector database and there are 15 options. Pinecone, Weaviate, Qdrant, Chroma, Milvus, pgvector, Turbo, Puffer, Redis, Elasticsearch. Okay, and every single one claim to be the fastest, cheapest, and the most scalable. So the benchmark contradicts each other. The pricing pages are designed to confuse you, and half the blogs post comparing them were written by the vendors themselves. So in this video, I'm going to cut through the noise. I'll compare the 6 most popular vector database head to head. I'll show you the real benchmarks, real pricing, real trade-offs, and at the end, I will give you the simple decision framework so you can pick the right one for your project in under 60 seconds. Let's go. So, what is a vector database actually? So before we compare, let's make sure that we are on the same page. A vector database stores embeddings that are the arrays of numbers that represent the meaning of the text, image, audio, whatever. When you search, you're not just matching the keywords, you're finding the vectors closest to your query vector in high dimensional space. So every vector database does this. The difference is how they do it, how they index, how they scale, how they filter, how much they cost, and how much work you have to do to keep them running. So there are two categories of vector database. One is purpose built, okay, and second is the extension. So purpose built is for the databases that are designed from scratch for vector search, like Pinecone, Weaviate, Qdrant, Chroma, Milvus, Folia. And extension is the traditional databases that added vector support, like pgvector for Postgres SQL, Redis with the vector search, Elasticsearch with KNN. So both work. The question is which trade-offs matter for your use case. Most of the most of these use a algorithm called HNSW, hierarchical navigable small world. So it's a graph-based index that lets you search billions of vectors without checking every single one. Okay, the search complexity grows logarithmically, not linearly. That's why the vector search at scale is even possible. Okay, let me introduce you to the 6 contenders. I'll give you each one about 90 seconds to make its case. Okay, let's move to the ChromaDB. Okay, this is the beginner's choice. Chroma is the simplest vector database to start with. It is open source, Apache 2.0 licensed, and runs locally with zero configuration. You just pip install it, create a collection, and start storing vectors. No server, no Docker, no API key. If you watch my coding tutorial, we use Chroma for this exact reason. So the 2025 Rust rewrite made it significantly faster, about 4x improvement in writes and queries. So it has built-in metadata filtering, full text search, and integrates with LangChain and Llama Index out of the box. So the limitation is scale. Chroma is optimized for developer speed. Okay, not production workloads. Under 10 million vectors, it is perfectly fine. Beyond that, the teams typically migrate to Qdrant, Pinecone, or Milvus. Think of Chroma as the SQLite of vector database. Okay, you prototype with it, maybe even run it in the production for small apps, but it's not for using for the billions of vectors. Okay. So this Chroma is around 20 milliseconds median search latency is there on 100K vectors at 384 dimensions, as you can see on screen. Let's move to the next slide. That is pgvector. It is the just use Postgres option. pgvector is a PostgreSQL extension that adds a vector column type. So you install it, add a column, create a HNSW index, and now you use Postgres database as a vector database. So one database, one connection string, and one backup strategy. The big selling point is that if you already running Postgres and most teams are there, okay, with zero new infrastructure, If they want, then you can use this. Okay, so you are embedding live next to your user data, your product data, your orders. So you can just join the vectors, the relation tables in a single SQL query. Try doing that with Pinecone. That's not possible. Now people used to say that pgvector was slow. That changed. With the pgvector scale extension from timescale, pgvector achieves 471 queries per second at 99% recall on 50 million vectors. That's actually 11x better than Qdrant at the same recall level in those benchmarks. But there are real caveats. Okay, like index builds can be slow and memory hungry. Filtered vector search is not optimized the way dedicated database handle it. Okay, you are basically on your own for pre-filter, post-filter strategies. Hybrid search with BM25 requires a manual setup, and some ORMs still don't fully support the PG vector. So the bottom line is under 50 million vectors and already on Postgres, PG vector is a no-brainer. Beyond that, you need to evaluate carefully. So this PG vector scale has 471 QPS at 99% recall on 50 million vectors. The time scale benchmark according to the 2025 stats. So next comes Qdrant. So the performance price sweet spot. Okay, it's a sweet spot for the performance and price. So Qdrant is an open source written in Rust and it's fast. It was designed from the ground up for the vector search with a strong focus on metadata filtering. If you are if your queries involve both similarity and complex filters, like find the similar products under $50 in the electronic category, or else the Qdrant is built for that. The standoff feature is the universal query API, so you can do multi-stage retrieval in a single query request. Fetch candidates with a compressed vector, okay, then rescore it with the full vector or even Colbert model also. So that's re-ranking built into the database layer. So Qdrant, okay, the Qdrant cloud has a generous free tier of 1 GB free forever. The managed service is SOC2 Type 2 certified. So you can also self-host on a Docker or a Kubernetes. Pricing is resource based, so you pay for the compute and the storage, not per query. So Qdrant is what I would call the sweet spot because it is cheaper than Pinecone, more production ready than Chroma, and give you the more control than fully managed option. So if I were starting a new project today and needed a dedicated vector database, so Qdrant would be my first look. So let's go to the next slide. That is Weaviate, the feature-rich hybrid engine. So Weaviate is an open source and has a deepest feature set of any vector database. It was one of the first to the market, okay, which means the ecosystem is mature. The distinguishing feature are its GraphQL API. So native hybrid search and built-in vectorization modules are also there. So native hybrid search is the big one. Okay, Weaviate runs BM25 and the vector search in parallel. Okay, and uses a fusion algorithm called relative score fusion. Unlike the standard reciprocal rank fusion, it preserves the original score magnitude, which can give better ranking. So you control the balance with a single alpha parameter. So Weaviate can also vectorize your data for you. Okay, like plug in an OpenAI or Cohere module, and it generates the embeddings on ingestion. And version 1.30 introduces server-side RAG, vector retrieval. Okay, and LLM generation in a single API call. So that's a full RAG pipeline inside the database. The trade-offs is resource consumption is more. Okay, above 50 million vectors, Weaviate needs more memory and compute than alternatives. Query latency is sub 100 milliseconds for RAG workloads, but at massive scale, okay, purpose-built systems like Pinecone or Milvus edge ahead. Okay, and the managed cloud pricing starts at $25 after just a 14 days free trial, the shortest free tier of the major options. So Weaviate is a Swiss Army knife. Okay, it does everything. The question is whether you need all those features or whether a simple tool is better for your use case. So Weaviate is HIPAA compliant and on AWS according to 2025. Okay, and SOC2 type 2 also, and server-side RAG is there in version 1.30. Just some stats. Let's move to the next one. That is Pinecone. Okay, the zero ops enterprise standard. Okay, Pinecone is fully managed serverless, and the closest thing to set it and forget it in the vector database world. You don't run servers, you don't manage indexes, you don't worry about the scaling. Pinecone handles all of it. It consistently delivers 2200 milliseconds P95 latency in production. It's SOC2 type 2, ISO 27001, GDPR aligned, and has completed a HIPAA attestation. If you if your compliance team needs checkboxes, Pinecone checks all of them. In January 2025, they launched Pinecone Assistant. Okay, a full RAG as a service endpoint. You upload the document, it handles the chunking, embedding, vector search, re-ranking, and answer generation. One API call that's interesting for teams that would want to skip the building the entire pipeline. The downside is cost and vendor lock-in. Pinecone is most expensive option at scale. Okay, read units can be unpredictable. A query with a metadata filter might consume around 5 to 10 read units instead of one. And because it's a proprietary, okay, if you want to leave, you are rebuilding everything. So Pinecone is like AWS Lambda for vectors. Okay, zero off, predictable enterprise grade. Okay, you pay as a premium for the convenience, and for many teams, the premium is worth it. Some quick stats, like Pinecone has 50K inserts per second. Okay, 5K QPS, supports 100K namespaces per plan. Okay, let's go to the next slide. That is Milvus. So it's the billion scale beast. Milvus is what you use when the other options can't keep up. Okay, it's an open source designed for billions of vectors and supports GPU acceleration. It has the longest track record at massive scale. The architecture is distributed by design, separate components for query, okay, data index and coordination that scale independently. So it supports more index type than any other option like HNSW, IVF, disk ANN, GPU indexes, you name it. And it handles streaming ingestion. Vectors are searchable immediately after insertion. Zilis is the managed cloud service for Milvus. So it led in low latency benchmarks alongside Pinecone and Qdrant. If you need to handle recommendation systems with hundreds of millions of items or real-time personalization at massive scale, Milvus is the proven choice. The trade-off is complexity. Milvus has a learning curve. Okay, the distributed deployment requires operational expertise. It's not what you use for a prototype or a team of two. It's what you use when you have a data engineering team and billions of vectors. Some quick stats. Milvus has 120K, nearly 120K inserts per second and is 20 millisecond query latency nearly, and has GPU acceleration support. Now let's put them all in one table. Okay, this is the screenshot movement. So as you can see, the features, architecture, open source, hybrid, scale limit and deployment we are using. For Chroma, it is embedded, PG extension is there, Qdrant is dedicated, Weaviate is dedicated, Pinecone is SaaS. Okay, these three are open source, Pinecone is not. Hybrid search, Chroma is basic, okay. pgvector we need to do manually. Qdrant is native, Weaviate is best in class, and Pinecone gives us it through API. Scale wise, Chroma scale limit is nearly 10 million vectors. Okay, pgvector is 50 million, Qdrant is billion, and Weaviate is nearly 100 million plus, and Pinecone is billions. Okay, so the deployment, we can do it self-host for Chroma, pgvector, both all for these three, both are possible, and Pinecone is cloud only. So you need to match your scale and infrastructure constraint before matching the features. Okay, let's move to the next slide. Yeah. So let's see the performance benchmark. Let's talk numbers. These benchmarks are from Vector DVV Eng. Okay. And independent tests in 2025 using 1 million vectors at 1536 dimension. Okay, which is a standard rack setup. Okay, Pinecone insert speed is around 50K, as you can see here. Okay, and query QPS is nearly 5K. Qdrant comes at 45K and with QPS around 4.5K. Same with Weaviate, 35K, 3.5K, pgvector is 30K and 3K. Chroma is 25K and 2K. Okay. And apart from this, filtered query QPS is also in these ranges only. So Pinecone and Qdrant lead on the raw speed. Weaviate trades some throughput for its richer features. Okay, PG vector is surprisingly competitive, especially with PG vector scale extension. Chroma is the slowest, but still plenty fast for most of the use cases under 10 million vectors. Yeah. But here's the thing nobody will tell you. For the most RAG applications, all of these are fast enough. If your retrieval takes 20 to 50 milliseconds, doesn't matter when the LLM takes 2 seconds to generate, right? Okay, if LLM takes 2 seconds, then 20 millisecond and 50 millisecond is negligible. So the bottleneck is almost never the vector database. So don't choose based on the benchmark alone, choose based on what else you need. So the LLM is the bottleneck, not the vector database. Okay. And pricing point of view, okay, pricing is where it gets interesting. Let me show you what 1 million vectors at 11536 dimension actually costs. Chroma is free forever. Okay, even the self-host or managed cost is normal negligible. PG Vector's self-hosted is $0 and managed is around $50 to $100. Qdrant is around $16 per month if you use VPS self-hosted. If managed, then $100 per month. Weaviate is $16 per month. Okay, and if managed, then 25 to $150 per month. And Pinecone is there's no self-host. Okay, only managed cost, which is $70 to $200 in range per month. And Milvus Zilis self-hosted is zero, but it is a complex setup. But if it is a managed cost, is around 65 to $200. Okay, Zilis has a free tier, but it's very short. Okay, so Chroma and PG Vector are essentially free if you are running locally or already have a Postgres Qdrant self-hosted on a $16 month. VPS handles millions of vectors. Pinecone convenience cost is around 2 to 3x more than the self-hosted alternatives. Whether that premium is worth it depends on your team and your time. Yeah. Let's move to the next slide. So here's the part you actually came for. Let me give you a simplest decision tree. First question you need to ask is, are you just prototyping or learning? If yes, then ChromaDB is the best. Zero setup, start in 30 seconds. Second question, are you already running PostgreSQL? And are you under 50 million vectors? If yes, then use PG Vector. One database, zero new infrastructure. Okay. Next question, do you need advanced filtering, good performance, and want control cost? Use Qdrant. Best balance on price, performance, and features. Fourth question, do you need rich hybrid search, built-in vectorization, or server-side RAG? Use Weaviate. Most features of any vector database is covered. Fifth question, do you need zero operational overhead and have enterprise compliance requirement? Use Pinecone. You're paying for convenience and that's fine. A bonus. Okay, if you are at billions of vectors with a dedicated data engineering team, Milvus or Zilis is your answer. Cool. So let's go to the next slide. This is the migration path most team follows. In practice, most teams follow a predictable path. They start with Chroma for prototyping. When they go to production, they either add pgvector if they are already using Postgres or deploy Qdrant or Weaviate. If the project grows to enterprise scale, some move to the Pinecone for the managed experience or Milvus for the billion scale workload. So the important thing is to not over engineer at the start. Pick the simplest option that works today. Okay. So you can always migrate later. And honestly, most RAG failures have nothing to do with the vector database. They are caused by bad chunking, bad embedding, or a missing re-ranking step. We need to fix those first. So according to a 2025 Databricks study, 73% of the RAG quality issues come from the ingestion pipeline, not the vector database. Yeah. So let's move to the next slide. So let me give you my honest, possible, controversial opinions. Okay, so hot take number one, pgvector in 2026 is a way better than people think. They just use Postgres. Okay, crowd used to be wrong. Okay, now with PG vector scale, they are mostly right, at least under 50 million vectors. The people saying PG vector is low are quoting 2023 benchmarks, not now. Hot take number two, Pinecone is overpriced for small teams, but correctly priced for the enterprise. If you are a startup with 2 developers, you don't need Pinecone. If you are a bank with a compliance team that needs SOC2 and HIPAA and zero operational risk, Pinecone is a bargain compared to hiring an SRE to manage the Qdrant. Hot take number three, Qdrant is the most underrated vector database right now. Rust performance, advanced filtering, generous free trial, great documentation. It deserves more attention. Hot take number four. Most people watching this video do not need a dedicated vector database at all. If you have under 1 million vectors, Chroma or PG vector will handle it easily. Stop optimizing infrastructure and optimize your chunking strategy instead. And the coldest take of all, the vector database you choose matter less than you think. A bad embedding model will make any vector database useless. A good embedding model will make any vector database work. Invest in your embedding and chunking first. So let me recap. Chroma is for prototyping, pgvector if you are on Postgres, Qdrant for the price performance sweet spot, Weaviate for maximum features, Pinecone for zero ops, enterprise, Milvus for billion scale. And remember, most RAG failures are not database problems, they are chunking problems, embedding problems, or retrieval problems. If you want to learn how to fix those, watch my full RAG series. I'll link it in the description and end screen. This was the part 7 of my RAG series. If this saved you hours of research, subscribe and share it with your team. And if you disagree with my hot takes, tell me which vector database you use and why in the comment. I'll see you in the next one. Fix those